All right, welcome back to the deep dive. Today we're digging into a really fascinating paper that came out of the University of Houston from Professor Marc Hamilton's lab.
Yeah, this one is a game changer.
It really feels like it. And our mission today is pretty specific. We're exploring what feels like a physiological loophole.
A loophole is the perfect word for it. It's essentially a way to sidestep the metabolic damage of sitting for hours, but without actually getting up.
Which sounds completely contradictory. I mean, we've all been told for years that sitting is the new smoking. But the big insight here isn't just, move more. It's about a very specific muscle, the soleus, and the fact that it uses fuel in a way that's, it's totally different from almost every other muscle in your body.
Right. So the soleus, for anyone who doesn't know, it's this flat muscle deep in your lower leg. It's underneath the big, prominent calf muscle that you can see.
And it's tiny. It's what, like 1% of your total body weight?
Barely 1%. But Hamilton's research found that its metabolic power, it punches so far above its weight class, it's incredible.
And this is where the anatomy gets really interesting. Most of our muscles are a mix of different fiber types. When we exercise, they burn through stored sugar glycogen. It's like a little battery pack.
And when that battery runs out, the muscle gets tired. That's fatigue.
Exactly. But the soleus is different, isn't it?
Completely different. It's about 88% slow twitch fibers. It's built for endurance to keep us upright, so it doesn't really rely on that internal glycogen battery.
So what does it use?
It pulls fuel directly from the bloodstream. It just sips on glucose and fats as it needs them. Hamilton calls it a metabolic sink.
So it's not running on battery power. It's plugged directly into the grid.
That's the perfect analogy. And because it's pulling from the grid, it doesn't get tired in the same way. You can keep it active for hours and hours.
Okay, here's the question I think everyone's going to have. I walk, I stand, I use my legs. Why isn't that activating this metabolic sink?
And that is the absolute key discovery in the paper. It all comes down to biomechanics. When you stand up or walk, your big calf muscle, the gastrocnemius, does all the heavy lifting. It just takes over.
It hogs the load.
It completely hogs the load. So to get the soleus to fire maximally, you actually have to find a way to sort of turn the gastrocnemius off.
And you do that by sitting.
You do that by sitting. Your knees have to be bent at a 90-degree angle. That specific angle creates slack in the big calf muscle, and it basically takes it out of the equation.
It mechanically disables it. So then the soleus is forced to do all the work.
Right. So you're sitting, feet flat, knees at 90. You lift your heel up high, keeping the ball of your foot on the ground, and then you just let it drop back down.
And the pace is pretty quick, like 1 rep a second.
About that, yeah.
Yeah.
An active lift and then a passive drop.
Okay, let's get to the data because these numbers are just staggering. And we should be clear, this isn't about burning calories for weight loss. This is about blood chemistry.
A totally different goal. The study found a 52% reduction in blood glucose spikes after a meal.
52%.
Wow. And maybe even more significant, a 60% reduction in the amount of insulin the body needed to release.
So you're taking a massive load off your pancreas. You're basically asking this tiny muscle to help manage your blood sugar.
That's exactly it. And it also doubled the rate of fat metabolism and helped clear triglycerides out of the blood.
I want to highlight one comparison that really stuck with me. They tested this Soleus Pushup against using a standing desk.
Right.
And I think we all assume standing is the gold standard for office health.
Sure, it's better than being completely still. But standing is static. The study found the Soleus Pushup increased energy expenditure by over 17% compared to sitting. Standing was only about 7 to 10% better.
So active targeted sitting was actually more metabolically beneficial than passive standing.
By a pretty wide margin, yeah. He calls it muscular medicine, which I think is a great term. It's not a substitute for real exercise.
All right, don't cancel your gym membership. This isn't for cardio or strength.
Not at all.
Yeah.
This is to flip your metabolic switch back on during all those hours when you're forced to be sedentary. It essentially turns the soleus into a kind of second heart for your metabolism.
It's just a compelling case for these small targeted movements.
And as we wrap up, maybe here's the thought to leave you with. If this one tiny ignored muscle that's just 1% of our body can regulate our systemic health without us even leaving our chair, what other powerful, dormant mechanisms might we be ignoring just because we haven't found the right way to switch them on?
Something to chew on. Thanks for listening to The Deep Dive.